Hi everyone, it's Miss Ava and I'm here with Calculina, and in this lesson we are going to go over graphing vertex form. If you're looking to learn how to solve quadratic equations or how to convert between the different forms, this is not the video. In this one we're strictly only just going to go over how to graph vertex form functions. And so vertex form is one of the three forms of quadratic equations that are typically taught in Algebra 1 and Algebra 2 courses. The other forms are standard form and intercept form. So let me just show you what those look like. Standard form looks like y equals ax squared plus bx plus c. Intercept form looks like y equals, and you might have an a, and then it would be like an x minus x1 times an x minus x2, where x1 and x2 are the x-intercept. And then vertex form, which is the one we're going to be going over, is y equals a times x minus h squared plus k, where h and k are the coordinates for the vertex of the parabola. So basically, I'm going to teach this to you by looking at examples. We're going to do a few examples where we go from the equation and then graph, and then some examples where we're going the other way around. We have a graph of a parabola, and then we have to put that into vertex form. If you want to learn about any of the other parts of the quadratic equation and understanding quadratics, look at some of my other videos and just some of the other concepts that I have, and feel free to let me know in the comments if you have any requests as well. If you're enjoying these videos, please like and subscribe as well. And don't forget, I have the PDF of everything that we're going to be going over, the notes and just the worksheets in the description of this video. So go ahead and download that so you can follow along with us. All right, let's get started. Okay, so here's the first example. So it says y equals, in parentheses, x plus 3 squared minus 2. And from this, we can get the vertex. That's the first thing we can get. So the vertex here is going to be -3 and -2. And do you notice what I did here, Calculina? I took the opposite sign of this one, because that's where it comes from. And then I kept the sign on this one. So whatever the sign you see here, you have to do the opposite sign of that. In this case is -3. And then for the number that's on the outside, we keep that one exactly the way it is. Yeah?
Okay.
And then you look for the a value. So the a value is usually the number that's right in front. It's multiplied right there. When you don't see anything like this, it implies that there's a invisible one and it's a positive. Cool?
Yes.
Okay, so now let's go ahead and graph the vertex over here. So that's at -3, -2. So that means it's right here. And we see that it's a positive, which tells us that the graph is going to open up. It's going to open in this direction. But we just need a few points to make sure that we're accurate. So this whole delta x, delta y thing, let me show you what I mean by that. What we're going to do is we're going to evaluate like points away from the vertex. So if we're 1 unit away from the vertex, that is going to be like a delta x of 1 because it's 1 unit away. Then I also want to get points for 2 units away from the vertex. So the way that you do this is you're going to do this 1 and then you square it. So 1 squared, and then the answer is 1. And then for this one, it's going to be 2 squared, and the answer is 4. So what that means is that when we go 1 unit to the right and to the left of the vertex, we have to go 1 unit up to get to the point. And then, so same thing on the other side, it's going to be like that. Then for the next point, if we go 2 units to the right of the vertex, so right there, then we have to go 4 units up. And then same thing on the other side. If we go 2 units to the left, we're going to go 4 units up. And so that gives you all the points that you need, or enough points to create this parabola right there. Cool?
Yes.
Okay, so this was the easy example, and you'll see why. Let's go ahead and do the next one. So here, what is going to be my vertex?
You're gonna write a negative 3 and negative 1.
Kind of. What's wrong with this?
Oh, it has to be a positive 3.
Yes, exactly. You have to switch the sign here. So make sure to remember that. That's going to be a positive 3. And I'm just going to color code still. That negative 1 comes from right here. And then what about the a value in this problem? What is that?
Is that the negative 2?
Yes, it is this negative 2. Okay, good. So we put that in here. And then now let's go ahead and draw the vertex on the graph. So that's going to be at 3 comma negative 1 right there. And then let's put in our delta values. So if we want to observe what is going to happen 1 unit to the right and to the left of the vertex, then let's put that over here, 1. And then what you're going to do this time is you need this a value. So what you do is you're going to write negative 2, and then in parentheses, this is where you use the 1 squared. So whatever that answer is, then you do the same thing for 2. It's going to be negative 2 times 2 squared. And write that number in there. For the first one, it's going to be 1 squared is just 1 times negative 2. That becomes negative 2. Then over here, 2 squared is 4 times the negative 2. That becomes negative 8. So this is telling us what to do when we go 1 over from the vertex and then 2 over from the vertex. Okay, let's draw those points in there. So going 1 to the right and to the left of the vertex means that you have to go 2 units down. So right there and then right there. And then what about when I go 2 units to the right and to the left of the vertex? So here and here, then what do I have to do?
You have to go down 8.
Yes, that is correct. So right there and then right there. Okay, and then that is good enough information for us to go ahead and draw the rest of the graph here like this. Good?
Yes.
Okay, what do you think I would have to do if I wanted to go 3 over to the right and left of the vertex? Then what would be the number?
Um, so then would you just do like, so you'd put a 3 in the delta x,
Yes,
and then would you do negative 2 and then 3 squared?
yes. So what's that going to give me?
That would be a negative 18.
Perfect. Yes, we would have to go down 18, which I can't even graph over here. But that's what we would have to do if we wanted to see what happens 3 units away from the vertex. Okay, let's do the next problem. So this one I'm going to have you try out. And for the folks watching at home, you can pause the video and see if you can get this one on your own as well and see if your answer matches ours. But okay, go ahead, Calculina. This one is all you. Tell me what to do.
Okay. So the vertex here is going to be a positive 2
Yes?
and a positive 2.
Perfect. And then the a value?
That's a negative 3.
Perfect. Okay, what now?
Now we graph the vertex.
Good. So that is 2 comma 2 right there. And then what's next?
Now we can figure out how much we have to go over and up or down. So on this chart, the delta x chart, uh, we can put a 1 and a 2.
Okay.
And then so for the 1, you're just going to do 1 squared. Oh, actually, wait, I'm sorry. You have to do negative 3 and then a 1 squared.
Yes.
And then for the 2, it's going to be the same thing. You do negative 3 and then 2 squared.
Perfect. Okay, tell me what the numbers are going to be.
Okay, so that one, the first one is going to be negative 3. And then the second one, is that going to be negative 12?
Yes.
Okay, so then now we can just go ahead and graph those. So that'll be like a 1 over on the right and left is going to make you go down 3.
Yes.
And then if you go 2 over from the vertex, then you're going to go down 12.
That is correct. So that is going to put us right here. Okay, so this graph is really, really skinny. It's like vertically stretched quite a bit right there compared to the regular graph that might be a bit more wider. But this is perfect, very nicely done. Okay, then let's do the next problem. So I'm going to show you how to do this one because this one's kind of a bit challenging, but let's take a look. Okay, so the vertex here obviously is going to be what?
It's a 2 and a 5.
Yes, 2, 5. And then the a value,
That's negative 3 over 4.
yes, awesome. So then we go ahead and graph the vertex. So 2, comma 5 right here. And then now we're going to figure out our values for the delta. So if we go 1 over, then we're going to write negative 3 over 4 times 1 squared. And then for going 2 over, we're going to do negative 3 over 4 and then 2 squared here. So the first part, what will that be?
That's going to be negative 3 over 4.
Yes, perfect. And then the next one, what is that going to give us?
That will give you, uh, is that going to be negative 3 over, I'm not really sure.
Okay, let's do this on the side. So that's negative 3 over 4, and then you're multiplying this by 4. Remember, this is 4 over 1. So we can either just multiply across or we can simplify these. So those two simplified, this becomes a 1 and this becomes a 1, and you end up with negative 3. Yeah?
Oh, okay, yes.
Good. So negative 3 is what we get right there. And then now we can just go ahead and graph these. Okay, so when it comes to graphing, we are going to go over 1 and down negative 3/4. So that would be about right there and then right here. And then if we go over 2 from the vertex, then we have to go down 3, right there and right there. Okay, so I mean, I guess this one isn't too bad to graph, but going backwards from here, when you have the graph and you're trying to write the equation, that can be a bit challenging. And especially when it's not so obvious what your a value should be. So you're going to see a couple of those examples. But how are you feeling about this so far, Calculina?
This is pretty good. I don't think it's too bad.
Okay, awesome. Well, let's keep going. So now we are doing the opposite. We have a graph and we have to come up with the equation for it. So first thing to start with, what is going to be the vertex?
Um, is that negative 4 comma 2?
Yes, perfect. So negative 4 comma 2. Okay, and then let's go ahead and start filling in the equation. Where would you like me to put it and what numbers do I put so far?
Um, okay. Well, you're going to put the negative 4 in the yellow spot,
Okay,
and then you put the 2 where the blue is. But the negative 4 and that other negative, those two will cancel out and become a positive.
okay, good. Yes, that's exactly what we are doing. That's why you end up switching the sign. Yeah,
Oh, okay.
exactly. Okay, and then now we have to figure out what our A value is going to be. And we can do that by looking at points that seem to cross the grid lines perfectly. So like right here and right here, those 2 points cross the grid line perfectly, right?
Yes.
Okay, and then you can also see it right here and right here. And then that's basically it. So you can just see like if you can go over 1 and see how far you had to go down to get to that next point, and you can tell that precisely, then that's your A value, like whatever that amount is. So in this case, it's just going to be a negative 1.
Oh, okay.
Yes, you have to make sure that you put the negative part because it's a downward facing parabola. So that is it. This is going to be our equation. But if that makes you uncomfortable because, you can't always rely on being able to tell exactly how far you have to go down just from going over one, then keep watching because we're going to go over some examples that are not as obvious. But the next one is not one of them. This one's just a practice one still. So it's still kind of starting off. Tell me what the vertex is going to be here.
The vertex is 1 comma 6.
Yes, awesome. So then in the equation,
That's going to be an x minus 1 in the parentheses. So you can leave that minus sign.
okay, good.
And then the blue part, you can put a 6 right there.
Okay, good. So I color coded it for you guys just to kind of start with, but obviously that's not what you have normally. But hopefully this just kind of helps you build the habit or the pattern of knowing where to look and where to put what. Okay, next part. What's the A value?
The A value, okay, you said that if you're going over 1, then you have to look at how far up or down you go.
Yes.
Okay, so in this case, if we're going down 2, then is that what the A value is?
Yes, exactly. It will be what do I put here?
A negative 2?
That's correct. All right, so still kind of easy, still on the easy level. Okay, now let's look at slightly more challenging ones. Okay, in this problem, I actually gave you what the vertex is just because if there was any confusion, so we can see it is negative 1/2, comma 1/2. So what do I put for each of these?
Um, okay, well, you're going to put inside the parentheses, you're going to have an x plus 1/2.
Yes, that's correct.
And then on the outside, you can also make that plus 1/2.
Perfect. Okay, and then now we have to figure out what our A value is, right? And in this problem, it's not quite as obvious because if you go over 1, right, then you'll be right here. And then maybe you don't want to take any guesses or whatever. So this is how you can do that situation if you're trying to figure out what your A should be. Look for another point where you can see it go through the grid line for sure. So I guess we can use these two, like that's 0, 0, and then this is negative 1, 0, so we can use those two. There's also these guys right here, but we already found one, so we're going to go with that. Okay, then what you do, you're going to use this equation still, but you leave an a in the a value. So you're going to say y equals a times x plus 1/2 squared, and then plus 1/2. And then you choose one of these 2 points and you plug it in. I think maybe if we plug in the 0, 0, that might be the easiest one. So if we plug in 0, 0, that means that instead of the y and the x, we're just plugging in zeros right there. So that's going to look like 0 equals a times 1/2 squared plus 1/2. And then we can subtract the 1/2 from both sides. So that'll give us negative 1/2 equals, and what's 1/2 squared? What is that going to give you?
Um, is that just 1/4?
Yes, that's correct. So 1 over 4a. And then we can multiply both sides by 4. And then this will cancel with this. And what do we have as our a in that case? So a will equal, what is this going to be?
Um, that would be negative 4 over 2. So just negative 2?
Exactly. So now we know what our a value is. And you can go ahead and put that right there. And that's the equation. Okay, one more of these kind of examples, the challenging ones. So in this one, what is the vertex?
Um, the vertex is negative 1, negative 1.
Okay, good. So negative 1, negative 1. So I left the equation totally blank here. So that means we have to start filling in everything on our own. So what would you like me to write?
Um, okay. Well, you can leave some space for A and then put a parentheses and then you put the X and you can close the parentheses with some space and put a square.
Okay, so you just created the frame, and now what would you like me to put everywhere else?
Okay, so inside the parentheses, you're going to put uh, x plus 1.
Yes.
And then on the outside, you can put minus 1.
Okay, good. And then now we just have to figure out our a value. Yeah?
Yes.
Okay. Is it obvious in this problem what it could be?
Uh, no, not really.
Exactly. Because if you went over 1, it's hard to tell what fraction that is. Like, how much did it actually go up or down? So this is another problem where you might not want to guess. So we find a point that we can identify, and it goes through the grid lines and makes it easy for us to be able to tell what that point is. So how's this one, and what are the coordinates on this point, Calculina?
Um, that is at 2 comma negative 2.
Okay, and so now what do we do?
So now you're going to write the equation, but you're going to leave the a in the equation.
Yes, so I'll write y equals, and I leave the a, it's going to be parentheses, x plus 1 squared minus 1. Okay, and what's next?
Mm, now you can plug in the point 2 negative 2 into the equation.
Yes, that's correct. Okay, so I plug in this one for y, so that's going to be negative 2 equals a, and then in parentheses we have the x, which is 2, plus 1 squared minus 1. Okay, and what's next?
Now we can add 1 to both sides.
Yes, we add 1 to both sides. And what do we get?
Okay, so you're going to have a negative 1 equals, and then on the other side, the 1 and negative 1 will cancel.
Okay,
And then you'll have a and then parentheses 2 plus 1 squared.
yes, but why don't we just actually do this part? So what is 2 plus 1?
Oh, that's 3.
Yes, and then we square 3, so what does that become?
Oh, that's a 9.
Yes, so it's really a times 9. And then what do I do now?
Um, you can just divide both sides by 9.
Yes, I divide both sides by 9, and then I get a equals negative 1 over 9. And so that means if this is negative 1 over 9, I just put that right in the front, and then this is our answer. Cool?
Yes.
Awesome. Well, I hope that was helpful for you guys, but remember that just watching this is not going to be enough. You definitely want to do some practice problems as well. And I would recommend even trying all of these problems again. So we have the PDF that you can get. Just check the description, you'll see the link for it, and let us know what you thought. Or if you have any questions, let us know in the comments.